Okay, so welcome to today's lab. In our previous MySQL labs and our homework assignments, we worked on some basic techniques for working with data. We were able to search for individual records using select statements and filtering with where. We generated summary information with group by. Today we are going to advance to the next step of our work with SQL. And learn how to link together two separate tables to write more advanced queries. So this is a super useful skill. Will enable us to get at some more interesting stories and work with more complicated databases. So in this lab, for the first time, we're going to be using a multi-table database. This is of boating accidents. This is records that are kept by the Coast Guard. And unlike previous exercises where we were working with single tables, this is really a true database in which you have information spread out over more than one table and linked together on common fields. Again, what you're going to do is just follow along with this lab, and you're going to create a script file that by the end of it, you're going to upload to Elm. So first step, you should have MySQL Workbench open in front of you. And we are going to create a new SQL file called 12 in class lab. So I'm just going to save this. And like before, we're just going to put a comment at the top with my name and date. So October 2018. Just like before previously, you're going to write this set SQL mode only full group by. If you remember from the last lesson, that's critical to making sure that things, our groupings work properly. So we're just going to run that. In this case, it was already on. And then you're just going to follow along with the instructions in the video. So before we get into joins, let's go ahead and take a look at the tables that we're going to be using for today's lab. So in our schema list over here on the left, we see this BARD. This is the Boating Accident Records database. It is arrayed into, well, there are really four main tables that we're going to be looking at. So accidents, deaths, injuries, and vessels. So this is sort of the master table of accidents. And then information about people who died or were injured, and the boats that were involved are stored in separate tables. And the record layout is available to link, but here's sort of a breakdown of what we're going to be looking at. So accidents, deaths, injuries, and vessels. And today we're really only going to be looking at the accidents table and the deaths table. So again, this is information that is collected by the Coast Guard when there's a boat crash where a person dies, a person disappears, a person is seriously injured, or a boat is damaged or lost. So let's go ahead and look at just the accidents table here. So I'm going to go ahead and throw in query. So select star, select all records from BARD. That's the name of the database. .accidents. We're going to run this. And we get 2,076 records. And let's see what we get. Basically, we get one record, one row, per accident. Each of them has this unique identifying number, the BARD ID. There's also a narrative what happened in the accident. So in this redacted narrative here, we get a sort of text description. We get the number of deaths, the number of people injured, the total damage causing the accident, the number of vessels involved, the state where it occurred, the time of day, the date, whether it was day or night, what body of water, where it was near, longitude and latitude, some information about the accident cause, whether there was equipment failure, all kinds of information, air temperature, water temperature, ambient air conditions, condition of the water, whether visibility was good, whether alcohol was involved. Okay, so and let's just go ahead and take a look here. Importantly for what we're about to do, I just want to write a query to make sure that there is indeed only one BARD ID per record in the database, as in this doesn't repeat. So let's go ahead and run this. So we're selecting the BARD ID, count star, so counting the number of rows as count from this table, BARD.accidents. We're grouping by the BARD ID, and then we're ordering by count descending. So let's go ahead and run that. And we've got one sort of the other way, ascending, and we still get one. So important for later, but there's only one of these in the table. Okay, so now let's look at the deaths table. So here I'm going to select star from bard.deaths. Put in a comment. Select all records from deaths table. Select all records from the accidents table. And check for unique ID repeats in accidents table. Okay, so let's come back here. Select all records from the deaths table. So select star from bard.deaths. Okay, so what do we have here? We have one record per death. So we've got a total of 179 rows. Meaning in this data set that we're working with, 179 people died. You've got this BARD ID, which is the same as appeared in our accidents table. It's a unique identifier. We've got information about which vessel the person was in or was riding in when they died. A unique identifier from the person, which is different than this unique identifier from the accident. The gender, and you can look in the documentation to see what -1 means and what 0 means. Deceased age, some demographic information, whether they disappeared or not, the cause of death, what they were doing at the time of the accident. Were they driving the boat? Were they an occupant? Were they wearing a life jacket? If so, what type of life jacket? What their blood alcohol level was, and the state, and some other information. Okay, so let's have a look here. So this BARD ID, we're going to write the same query we did to check for whether or not these repeat or not. Or if, like the accidents table, there is only one BARD ID that repeats only once, as in there's only one iteration of this in the table. So I'm going to go ahead and run the query. So check for unique ID repeats in deaths table. Okay, so we're selecting BARD ID, count star as count, renaming the column count, from bard.deaths. We're grouping by BARD ID, and we're ordering by count descending. Okay, so if you see here, we've got for this BARD ID, it appears 3 times, this one 3 times. There's several where it appears twice, and then a lot where it appears once. Okay, so why is this? Well, this is because, unlike the accidents table, there's one record per accident. In the deaths table, you can actually have multiple people die in a single accident. So in this case, there are 3 records because 3 different people died in this accident. Let's go ahead and take a look at one of these accidents. So this is going to be MD-2016-0161. So I'm just going to write, take a look at deaths in MD 2016-0161. And we are selecting star from bard.deaths, and then we just have a simple where clause where bard ID equals MD-2016-0161. So let's run that. Okay, and we see there are 3 records. So what do we learn from this? Well, 3 people died in this accident. They were all men. That's the gender for -1. They were all right about 50 years old. 2 of them did not disappear, the driver and one occupant, and the other, this one, disappeared. They were all wearing Type 1 personal flotation devices. This happened in 2016. Okay, so we can actually get more information about this incident in which these people died by going to look at that accident in our accidents table. So I'm going to pull up a new query. So we're going to take a look at accidents in MD 2016 0161. So it's going to be the same query as above. The only difference is instead of selecting star from bard.accidents, we're selecting star from instead of selecting star from bard.deaths, we're selecting star from bard.accidents. Okay, let's run that. Okay, so we only get one of them. 3 people died. That's why we got 3 from our deaths table. But when we run it in accidents, we only get 1. So what did we learn? Well, there's some long information about the narrative, which you can go in and read. We know this happened in late November 2016. We know the water temperature was in the mid-50s, which is pretty cold. We know that 3 people died and 1 was injured. So there's an additional person not reflected in the deaths table who was injured but did not die in the accident. We know there was 1 vessel involved, so it's not like this collided with another boat. We know that it happened late at night, so somewhere around 9 o'clock in late November on a Sunday. Potomac River, off of St. Mary's City, hazardous waters, and weather. So we get a lot of information there. Okay, so to do that, though, we had to write 2 queries, and we had to kind of like bounce back between them, which is kind of annoying. But I'm going to show you how we can essentially pull together the information that we acquired from the accidents table about this accident and the deaths table all in one by using joins. So our goal here with this concept we're about to learn called joins is that we want to return information about each of the 3 deaths in this accident, MD 2016-0161. But when we write a query, we don't want to have to write 2 separate queries where we're querying accidents and then querying deaths. We want to write 1 query that pulls back all of the information. So I'm going to paste that in, and we're going to run it, and then we're going to break it down. Okay, so first I'm going to make a comment saying return 1 table with information about both the accident and deaths for accident number MD 2016-0161. Okay, so I'll go through and explain this for a second, but for now let's just go ahead and run this and see what we get back. So select star from bard.accidents, join bard.deaths on bard.accidents.bardid equals bard.deaths.bardid, and then we're throwing in a where clause, where bard.accidents.bardid is MD 2016-0161. Okay, so let's take a look at what we get back. So we get 3 records. 1 for each death in accident MD 2016-0161. Okay, so this looks like when we just queried the deaths table. So on the left side here, what we're looking at are all of the columns from the accidents table. So BARD ID, the case ID, the narrative, the number of deaths, the number injured, the total damage, number of vessels involved, all this, all the way over to right here. That's where the accidents table ends. And one thing I want you to notice about all of the columns in this table, all these things repeat, right? This, and this are the same. State case ID is all the same. The narrative is all the same. The number of deaths, all those identical, all right? So we get to here. And now we've got the BARD ID from our deaths table. And then we've got information about each death. So this is the first death, the 55-year-old man who died. This is the second death, the 52-year-old man who died. Third death, the 48-year-old man who died. So we've just done a join. We have returned all of the records from our deaths table where the BARD ID was MD 2016-0161. And then we've mashed up all of the information from the accidents table for that particular accident with each of these records. Okay. So I just want to break down what's happening here in the statement. So what we've done is we've said select star. So you are used to that. That says select all of the fields. And in the case of the join, it means all the fields from both tables. We've also got this where clause, which you've done before, where we're limiting what is returned, the records that are returned, just to this one particular accident. We've also got the from clause, but this is new. So what we're saying here is from BARD.accidents, and then we join it with BARD.deaths, so from the first table, join it with the second table, on. So we need to join it on something. So the unique identifier in this case, in the accidents table, BARD ID, what we're saying is anytime the BARD ID from the accidents table is the exact same as the BARD ID in the deaths table, put them together and match them up, which is why you get information from the accidents table for this BARD ID MD 2016-0161, each of these three records, with the BARD ID in the deaths table MD 2016-0161. There's lots of other BARD IDs, both in the accidents table and in the deaths table. But this join was smart enough to know to put them together only when this value in the deaths table is equal to this value in the accidents table. Okay, so let's take a look a little bit closer at how this join works by doing it without the where clause. So just to start, we're going to start with a select statement just to look at return all records in our accidents table. So we're selecting star from BARD.accidents. We're running that. Okay. So we get 2,000 rows here. 2,076 rows to be precise. Okay. Now, let's just keep count of that. So 2,076. Now we're going to return all the records in our deaths table. And we're going to run that. And we get 179 deaths. So keep those in mind, right? Okay. Now let's join the two tables together. And again, we're going to do it without the where clause. So we are going to return all records where BARD ID in deaths is the same as BARD ID in accidents, and return a table where the fields from the two tables are mashed together. Okay, so select star from BARD.accidents. We're joining it to BARD.deaths. And how are we joining it? We're joining it by looking at the BARD ID in accidents and the BARD ID in deaths. And if they are the same, then we put those two records together. So let's run that. Okay. So here we get 179 records. On the left, we have all of the fields from the accidents table. And then starting here, we have all of the fields from the deaths table. And if you scroll over and look here, you'll see some cases where the BARD ID repeats. So here's MD 2016-03. Right below it is MD 2016-03. This information is the same as this information in state case ID. Same with redacted narrative, etc., etc. That's because there were 2 deaths in this particular accident, so this information repeated twice. So remember, there were a total of 2,076 accidents in our accidents table in total. So 2,000 separate accidents in our database. But what's returned is not that number, but the number of deaths, 179, when we do this join. And that's because, again, we're only returning those records where the BARD ID from accidents is the same as it is in deaths. There are a whole lot of records in the accidents table that do not have a corresponding BARD ID in the deaths table because nobody died in that accident. And that's why those records are not returned. Okay, so again, when we ran this particular query, when we're joining accidents to deaths, we end up with the accident fields on the left, and then we have the death fields on the right, starting right here. So we can flip it, and we can basically do the same exact query, but we can go in the other direction. So this is same as query above, but joining in the opposite direction. So we're selecting star from BARD.deaths. We're joining it to BARD.accidents. We're making the join on the on the field in each table where there are identical values, in this case the BARD ID. So I'm going to run that. And now on the left we have the information from deaths. And then starting right about here, we have the information from accidents. Okay. So when we are writing these kinds of queries, you'll notice now we are having to refer to individual table names with things like BARD.deaths, BARD.accidents. We're trying to refer to this specific column ID, so then we have to write BARD.deaths, the name of the field, There's a little trick we can do to shorten the lengths of the table names to give them nicknames. And this is sort of similar to how we rename summary columns. Like instead of saying like count star, we'll say like select count star as number records. So in the same way that we can rename fields, we can also rename tables, and that's going to save us some time in the future. So this same query here, we are going to shorten this by giving our tables a nickname. In this case, we're going to refer to the BARD.deaths table just as the letter D, and we're going to refer to the BARD.accidents table just as the letter A. So using nicknames to do the same query as above. Okay, so select star from BARD.deaths, but this time we're calling this D. So from BARD.deaths as D, join BARD.accidents as A. So essentially we're renaming BARD.deaths just as the letter D, and we're renaming BARD.accidents just as the letter A. And then we get here to do the join, where we are linking together, looking for common records in the deaths table BARD ID field and the accidents table BARD ID field. We just say d.BARD ID instead of BARD.deaths.BARD ID, and we just say a.BARD ID instead of BARD.accidents.BARD ID. So when we run this, we get the exact same thing. 179 records, 1 record per death, where we have repeats of the accident information in cases where there was more than one death. And in fact, we don't even have to use the as. We have to use as when we're renaming fields, but with tables, you can actually write a slightly tighter query by doing this. So select star from bard.deaths D, I've taken out the word as there, join bard.accidents A on d.bardid equals a.bardid. It knows enough to know that when I just put that there without as, what I mean is rename bard.deaths and refer to it just as the letter D. This could be anything, by the way. You could rename it death table, or you could use 2 letters. Doesn't have to be 1 letter, but we're writing very efficient queries here. So when I run that, we get the exact same thing. Okay. So that is the basic structure of a join. And I know this may be a little tricky, may be a little time to get used to, but what we're doing is we are selecting records from table 1. We're joining it to table 2. We're doing the join on a field that they share in common. In this case, there's both a Bard ID table in our deaths table and a Bard ID column field in our accidents table. And we're saying where those values are the same, put them together. So once we've done the join, we can basically do any of the other things we have previously learned in SQL. So this means filtering, sorting, selecting only certain columns, grouping, calculating summary statistics, and a whole lot more. So let's take a look at a few examples here. So this next query I'm going to show you is essentially the same as the query above. The only difference is instead of selecting all of these fields, this is a pretty long, unwieldy table, I'm only going to select the Bard ID from deaths, the cause of death from the deaths table, the role of the person on the boat, whether they were driving a passenger or something else, and then from the accidents table, I'm going to select the year, and then I'm going to do the same join. So we're going to write select Bard ID, cause of death, and deceased role from deaths table, and year from accidents table. Okay, and that is going to look like this. Select d.bardid, d.cause of death, d.deceased role, and a.year from bard deaths D. Join it to bard.accidents A on the Bard ID column. So where the Bard ID column is the same in the deaths table as it is in the accidents table. And note, for this join to work, I don't actually have to select the a.bard ID up here. In fact, I don't even have to select either of them, and it would still work. And the other thing to point out is that I haven't gotten down in the query yet to actually renaming this table from bard.deaths to renaming it as D, but I can still refer to it in my select statement as D. So you don't actually have to write out bard.deaths, and that's where this really starts to get powerful when you're selecting lots of different column names from different tables. When you're joining multiple tables, it can be a lot easier. All right, so we run that, and we get 4 columns, 1 record per death, total of 179 rows, with only Bard ID, cause of death, deceased role, and the year. We can also filter. So we did one example of this with our where clause earlier, just to look at that one particular accident, but we can even do something a little more advanced. So in this particular case, what I want to do is write a query to select all records from both deaths and accidents where the age of the deceased is less than 18. So I want all minors, basically, who died in accidents. And that's coming from the deaths table. In the year 2016, and in this case I'm going to pull the year from the accidents table in 2016, and that's coming from accidents table. Okay, so query is going to look something like this. So select star from bar.deaths, which we're renaming as D, and we're joining it to bar.accidents, which we're renaming as A, where the BARD IDs are the same in both the deaths and accidents table, where the deceased age from the deaths table is less than 18, and the year from the accidents table is less than 2016. Let's run it, and we get exactly one record back. This is a 9-year-old whose cause of death was trauma and was not wearing a life jacket. Okay. We can also calculate summary statistics using group by. So in this query I'm going to show you here, we're going to calculate the total number of each cause of death. We're going to take that from the deaths table in each year, and we're going to pull that from the accidents table. So we're going to group by both the year and then cause of death. And we'll take a look at that table, and I'll show you what I mean by that. All right, so we are calculating total number of each cause of death in each year. Okay, so we're going to select the year from the accidents table, the cause of death from the deaths table, and then count star, so counting the number of rows as count, so the column will be renamed count, from bar.deaths, which we're renaming D, and note that we've already called that up here. We're joining it to bar.accidents, which we're renaming A, and note that we're calling A up here. On, again, we're doing all the same here, so the unique ID in BARD ID in the deaths table must match the BARD ID in the accidents table. And then we're grouping by year and then cause of death. And then we're going to order it by year and then by cause of death. So we should have a nice table that has one record per year in cause of death. Okay. And that's what we have. In 2005, we see there were 14 drownings, 1 trauma, 1 unknown. 2006, we had 2 cardiac arrests, 6 drowning, 1 other, 1 trauma, 1 unknown, and so on. So there are a couple sort of major things to think about when doing joins. I know we've made them look really easy here, but we happen to be working with a data set that doesn't really have any of the problems that you will sometimes encounter with joins. Just as a way of introducing them to you so you don't get too scared of them. But there's a couple things that typically pop up that can cause joins to go wrong. So the first thing is you have to make sure that when you are doing a join, you are joining on a field in which the values in one table are also going to be found in another table. So as an example of that, I'm going to show you a potential join here using our deaths and accidents table. So select star from bar.deaths as D, so renaming deaths D. We're joining it bar.accidents A on D, so the BARD ID from the deaths table with the year in the ID in the accidents table. So when we run that, let's look what happens. So we get back no records. We don't get an error, but we get back no records. So why is that? So let's take a look at the BARD ID, select star from BARD.deaths. Okay. So there's the BARD ID, right? It's DE-2016-0025. That's the general pattern we see. And then let's take a look at select star from BARD.accidents. And let's take a look at the year field there. Okay. So all of the values here are four number years. None of these values here are going to be found in the BARD ID field in deaths because they're completely different. So the joins need to be on columns with similar values, otherwise they will never return any records. And by the way, the ID doesn't need to be the same. The name of the field doesn't need to be the same. So in this case, you happen to have a field called BARD ID in both the accidents table and the deaths table. And when we run it, we get the join that works properly because the values in BARD ID from the deaths table are the same as the BARD ID in the accidents table. Just trying to find that here real quick. Right there. If for some reason, this is the BARD ID from the accident table, let's say this was the word unique ID. And this, from the deaths table, is called BARD ID. When I run this, that's not going to work because, in fact, it is called BARD ID in the accidents table. But if it were called unique ID, this query would work correctly. What matters is the values in the field, not the name of the field. So it doesn't need to be the same in both tables, although frequently that will be the case. So you can also have issues when you are doing joins, especially the kind of join we're doing here, which are called inner joins, and I'll explain that in a little more detail. You're only ever going to get a record back if there's a shared value in the join field in both of these tables. So as an example, let's take a look back at the query that we did where we just looked at the 3 deaths in accident MD 2016-0161. Okay. So this query worked because there were, in the deaths table, there were 3 records with the BARD ID of MD 2016-0161, these 3 here. And in the accidents table, there was 1 record where we had the BARD ID of the same number. So when we did the join, what happens here is the BARD ID for accident finds the BARD ID in the deaths table, the first one, and then it matches again to the second death from that accident, and it matches a third time, the same individual record, to the accident ID, to the BARD ID in deaths. Okay. So if for some reason, though, this particular BARD ID for this deaths, for these 3 deaths, MD 2016-0161, did not appear in our accidents table, nothing would be returned here. We would get no records back because this kind of join, called an inner join, says only return records when there is a shared value in the join field for both of these tables. Similarly, let's suppose that instead of having 1 unique value for MD 2016-0161 in our accidents table, let's say through happenstance, somebody screwed up and assigned the same case number to 2 different accidents. And in our deaths field, in our deaths table, we had 3 deaths where that accident number existed. What would be returned here, instead of 3 records, we would actually get 6 records. You would get the first instance of MD 2016-0161 in our accidents table, matching up to the first death in our deaths table with that BARD ID. Then it would match the second one. then it would match the third one. And then the second instance of the BARD ID MD 2016-0161 in our accidents table would do that matching again. So you would get 3 sets of record matched to the first one in the accidents table and 3 sets of records to the second one. That's why it can be really, really important to count to make sure that you're not getting repeat values. In this case, we were getting 179 rows returned pretty consistently, which was the same number of deaths. So we could feel somewhat confident that we weren't getting that kind of repeat. So just something to pay attention to for the future. For the moment, we'll be working with cleaner data sets. Okay, so up until now, we have been working with what are called inner joins here. And so there are actually several different types of joins. For the most part, we're only going to be working with inner joins, but on your final analysis project, you may find it useful to do outer joins. So so I want to look at some of these quickly here at the different types of joins. So W3 Schools has a pretty nice breakdown of this. And I think it's useful to think about these things as Venn diagrams. So the types of joins we've been doing are what are called inner joins. So what we're saying is you take records from a table, table 1, you take records from table 2, and you look at a common field. And you only return those records where the common field you're looking at from table 1 has a corresponding value in table 2. So that's an inner join. Which is why if you have some records in table 1 for which there is no corresponding value from table 2, they might be completely left out. So that's something to think about when you're doing these kinds of inner joins, and you may not be getting the results you expect. Then there's something called a left join. So a left join is where you return all of the records from table 1, even if there is no corresponding record in table 2 on that common field in which you're joining. So practically speaking, what that means is often you'll have a table where you'll have all the complete table from table 1, and then for some of the records, for the fields from table 2, you'll have values, and for some of them, they'll be blank. A right join is essentially the same thing, just the other direction. So you may have you'll have a full table from table 2, all of the records, and for those where there was a corresponding value in table 1, you'll have those, but you'll also have a lot of blank cells kind of on this side. And then you also have what's called a full outer join, where you'll get all of the records from table 1, all of the records from table 2. In cases where there was a matching value for one of in both of the fields on which you're joining, you'll have information all the way across. But in some cases, you'll have blank spaces on the left side and information on the right for a given row. And in some cases, you'll have the opposite. Okay, so I just want to talk lastly a little bit conceptually about why we might do joins, or why are joins needed. And I guess another way of thinking about it is, why do we work with databases where information is stored in separate tables? And there are several reasons for this, and most of the main ones have to do with best practices for database construction. So if you think about a situation in which we have a table with accidents, like in our voting database, and we have a table with the people who died in those accidents, in our, as in our voting database separately. The reason that we have that, it is generally best practice when creating databases to avoid repeating information. So conceivably, right out of the box, you could have a database that looks like, um, uh, that is a single table that looks like this, where you have on the left side this information about the crash. On the right side, information about the person who died in the crash. The information about the people who died in the crash is repeated here, or is not repeated here. It's separate. It's different. But the information about what happened in the accident, the information from our accident table, is repeated over and over. This is generally not best practice. You want to avoid redundancy when creating a database, so you don't have to store information like this. In very large databases, this would take a lot of extra space, and it's unnecessary. So the person who built this, constructed this database, in this case it's a government database, was built with that in mind. So the reason we sort of have to learn to do joins is that many of the databases we work with will be constructed in just this manner to avoid efficiency. The other reason that you might do joins, and that's not the case with this table, is that often information is stored in a way in the database in the most efficient way possible. So, for example, let's take a look at each of the people who died in this case, right? They are all men. In this case, men means, we know they're men because they are -1. And if we look at our record layout for this, we see deceased gender -1 equals male, 0 equals female. Okay, so why do they use -1 and 0 there when they could write male and female? The short answer is that this is more efficient. This takes 2 characters, -1, whereas the word male takes 4 characters. Female, 0, takes 6 characters, whereas the 0 takes 1 character. It's a more efficient way of doing it. So often what you will see is these kind of, there will be what are called lookup tables, where the values for a particular field are stored in a separate table, and it's easy to write a query where you are spitting out or printing a table with the word male here instead of -1 by joining it to the lookup table. So you can imagine there's like a really tiny table here as part of our database where it was -1 is the first row, and that is the value in a field like this. So value, male, female, -1, 0. This would be a really simple table with 2 fields and 2 rows. And you could join it back to deceased gender. So wherever you see -1, you are joining it here to here and pulling in the word male. That's not the case with this database, but many databases we use will do that. In other cases, sometimes we want to create a summary table or filter out a certain set of records and then join it back to our existing master tables. That's a process we'll go into in a little more detail later on. And then lastly, this joining process is particularly useful for joining together 2 seemingly unrelated databases. Sometimes we call this enterprise joins, where we can discover new information. So things like matching up court records with lists of bus drivers, or matching up campaign contributors with lists of lobbyists, these sorts of enterprise joins allow us to get new stories. Okay, so for the end of this lesson, I want you to write 3 queries that use joins using the boat accidents table and the boat deaths table. Think of some questions and write some queries using joins, and then put them in your script file before you submit.